Hello. This is weird. Let's just acknowledge that it's weird. But I'm going to go through some of the biodiversity calculations that I set you in the PowerPoint and questions. So it's much easier, I think, for you to see me going through it than it is for me to just give you the answer and let you work it out for yourself. So I'm going to go through the two examples that are on the PowerPoint, starting with the one about the different species of flowers, the different colours, on slide number 4. So the way I would set it out was something like this. The passage tells us that we have 3 red flowers, and that's going to be little n when we come back to that in a sec. So we've got 3 of them. We've got white flowers, there's 5 of those, and then blue flowers, 3 of those. And it says that our total, which is represented by a capital N, is 11. Now, the formula we need to use for the index of diversity is as follows. Diversity is equal to, just going to move that up into frame slightly, the total number of flowers, so capital N, times total minus 1, divided by, now this squiggly sideways M thing means sum of, and I'll explain that in a second. The number of each individual species, so little n, times little n minus 1. That was 11, I didn't finish that, I'm sorry. So this top line we can do really easily. So we know the total is 11 flowers, so we can sub in 11. 11 minus 1, which we can sub again, 10. We can come back to that, and that'll be super easy to work out. The more difficult bit is this bottom part. So what I would do is I'd go up here. So we have to multiply each individual species by its number minus 1. So I do another column up here like this when setting it out. So our n for red is 3, so 3 minus 1 is 2. 5 minus 1, 4. 3 minus 1, 2. And then we have to multiply them, because n outside the brackets means we multiply it by what's inside the brackets. So we do 3 times 2, 5 times 4, 3 times 2. So that's 6, 20, and 6 again. And here's where we come back to the sum of. So we now add all of those individual numbers that we multiplied together to give us 32. And that's now our bottom line. So 11 times 10 is 110 divided by 32. .4375, but remember, calculate 3 significant figures because it says it in the question and it's good practice anyway. 1, 2, 3, 7 rounds that up, 3.44. Okay, move on to slide 5. Try that yourself. Pause the video and then I'll go through that. Okay, so this is moving on to slide 5 now, where you've got 2 different habitats. Your table looks very similar. two different habitats, X and Y, and you're going to work out the diversity index, the index of diversity, sorry, for each of them, so that you can then compare to see which habitat has the most diverse ecosystem. So we need our formula. Diversity equal to total times total minus 1, capital N, divided by the sum of each individual species times each species minus 1. So when you get a table of information, it's important to identify which symbols match which bits. So our total is the capital N is 50. So when we work this out, our top lines are going to be identical for both equations. So we only need to work that out once. And then the little n is the number of each individual species, which are these numbers here. So I'm just going to add a little n above there to remind us that that's what those are. So top line first, our total is 50. 50 minus 1, which is the same as 50 brackets 49. And we can come back to that later. Next, we need to do the bottom line, which is each individual one multiplied by that number minus 1, which for x is going to be identical. So n minus 1, let's add in another column there. It's going to be 9, 9, 9, 9, and 9. Multiply those out, we get 90. Remember, this figure means sum of, so we need to add these all up. So that's 90 times 5, which is 450. That's our sum of, so that's our bottom line for x. So for x, we've now got our top line, which is 50 times 49 over 450. 50 times 49 to 450 over 450 is 5.4 recurring, so 5.4444 to eternity. 3 significant figures, 1, 2, 3, doesn't change it, so 5.44. The further away from 1, the more biodiverse an area is. So that's quite a biodiverse area. If I push this up just so we can do y now. So our top line's identical because we have the same total. So we can stick that down immediately. We now just need to work out, let's have a frame for these, which is the number of each species times by the number minus 1. So we need to make ourselves a new column, n minus 1. So 3 minus 1 is 2, is 4, is 1, is 35, is 3. We multiply those, 6, 20, 2. That requires a calculator. 1260, 12. So then you add these all up, plus 12, plus 2, plus 20, plus 6, which gives us our sum of Yep. Then we can take our sum of and put it back into our equation down here. So 2450 divided by 1300 gives us 1.8846, etc. 3 significant figures, 1, 2, 3, 4 doesn't change it, 1.88, which you can just about see there. Yeah. So we've got two numbers now, so we can compare habitat X and habitat Y. Habitat X is a number that's much further away from 1 than our answer for Y, which is much closer to 1. So X is the more biodiverse habitat. If you go back, that's kind of backed up by our results, because in habitat Y, you had a few individuals, but loads of species D, whereas over here it was a more even spread. So this, because it has an overwhelming population of D, it's not very biodiverse. This one, all the species have an equal representation, more biodiverse. Have a go at the other past paper questions now and let me know how you get on. If you're still struggling, send me a picture of your calculations. I'll see if I can work out where you're going wrong, but no promises. Bye.